ओके सो वेलकम बैक माय डियर लर्नर्स। आज हम पढ़ने वाले हैं क्लास 11th चैप्टर नंबर 5 और वी से द यूनिट नंबर 5 दैट इज thermodynamics. That is a very interesting topic, but for the 11th standard student that may such a hard topic, but you do not think as a hard, because it is based on mathematical tools as well as some conceptual information about the thermodynamics. Okay, it is a practical based topic, so you can't afraid about the terms that we are using in future. Okay, so first, after seeing this word thermodynamics, we have to understand that what is the meaning of this word. So that is a made from the two words thermo as well as dynamics. Thermo, generally we are using these words in our daily life, that thermal flask, thermal cup, in thermal you say thermal utensils. Okay, so means what is the mean of that word thermal means there is some relation with heat is involved in that word. So basically, first of all, you have to just think about the heat only, not more than that. Then the mean of dynamic is that there is some movement, there is some flow. So the heat flow in our chemical reaction, the heat movement in our chemical reaction, we have to identify or rectify in that chapter. What the thermodynamics are involved in our chemical reaction. Okay, so we are starting from directly. So these are our objectives that are mentioned in our book. We have to all we will go through all the objectives that are present in our slide. First, we will go through and explain the terms system and surrounding. What is the mean of system? What is the mean of surrounding? That is a very basic topic. Then we will go on the next topic, that discriminate between the closed, open and isolated system. That is our second topic which we have to study. Then third one is explain internal energy, work and heat. So basically the thermodynamics is start from the third topic properly. Then state the first law of thermodynamics and express it mathematically terms. Then calculate the energy changes, work, heat and contribution in chemical system. Then explain the functions, this energy functions, enthalpy and the internal energy. Then correlate with the change in the internal energy as well as the enthalpy. Then define the standard state of the enthalpy change, calculate enthalpy changes for the various types of the reaction, and many more. It's like a state and apply Hess law of the constant in summation, and explain the entropy and Gibbs free energy. That's the last topic we have to study. Okay, so basically we have to see in our daily life that we have put so many reaction in our chemical laboratory. For example, when we add the water in NaOH pellets, so there is some NaOH pellets in our chemical laboratory. I think that is visible. Okay, chemical, these are the chemical, or we say the NaOH pellets. Okay, these NaOH pellets are solid, we have to see in our laboratory. Okay, when we add some water in that, the temperature is suddenly changed from the room temperature to around 30 or 40 degrees Celsius or more than that. So what happened with that means, where the heat from where the heat is came, and what is the flow. Okay, Means what is the role of the heat in that? So that is the exothermicity, endothermicity. What is that? So we have to study all the terms, so don't worry about that. So that is a basic fundamental you have to understand before they start the chapter. Starting from the directly, not that this one. Okay, so directly we are starting from the thermodynamics terms. What are the terms that we are going to use in our chapter? So we are interested in chemical reactions, the energy changes accompanying them. For this we need to know certain thermodynamics terms that we are discussing. So what is the terms? Starting from the first term, that is what is the system, and second is what is the surrounding. Okay, so basically system is a thermodynamics. System in thermodynamics refers to the part of the universe. Universe means whole, the whole our surrounding systems, means whole our environment. Okay, that is belongs to the universe. Okay, so thermodynamics refers to that part of the universe in which observation are made, and remaining universe constitute the surrounding. So the part of the universe, the part of our environment that we are using for our observation. Okay, and the remaining is universe, means the other than of the system is surrounding. Okay, for example, there is your house, means the total house, and there is one room. So we are discussing about that room. Okay, that is our system, and the whole remaining part, this one I have to change the color so you have to get the better understanding. So that one, the remaining part, that is the surrounding. So we can express like that, the house is made up of surrounding as well as system, because both are the part of the house. So that's like that, the universe is a combination of the, or a combined form of mix up of system and surrounding. Okay. However, the entire universe other than the system is not affected by the changes taking place in the system. Therefore, all the particles purpose the surrounding are that portion of the remaining universe which can interact with the system. For example, we can say if we are studying the reaction between the two substances A and B kept in a beaker, so there is some beaker, the A is there and B is there. The beaker containing the reaction mixture is system, and the room where the beaker is kept in the surrounding. So the same thing that I have explained in that example. So the same thing is mentioned here. If for example there is a beaker and you have to put the water and NaOH in that, so that beaker containing the reaction mixture, the beaker is a system, because we are now going to observe that reactions. So the specific part of the reaction that we have to observe, that is a system, and the remaining where the beaker is present, that is a surrounding, means the room where the beaker is kept, that is a surrounding. Okay, I think you have to understand. Then the next thing is that there is some separation of the separation between the, I think, sorry, there is a separation between the surrounding and the system. What is the main thing of the separation? That's boundaries, because the solution of NaOH and H2O is not directly related to the surrounding, that may separated by the some boundaries. For example, there's a beaker, it is made up of uh, uh, thermal insulator, or we can say the word in very easy form, that may have the foam or glass. So the glass boundaries are a separating wall for this system and surrounding. Okay, that are called the boundary. The system from the surroundings called a boundary, as I discussed. Okay, this is designed to allow us to control and keep track of the movement, matter, and the energy of the system. That what is the role of these boundaries? These are separator between the system and surrounding. So we can easily control the heat as well as the heat. We can say the energy as well as the matter movement between the surrounding and system. Okay. So we can keep track and control all the movement of the matter and energy in or out of the system. So next we are discussing that line. Okay, type of the system. What is the type of the system we have to read or we have to seen in our daily life? For example, we have to see open system first. So what is the type of the system we have to study? The open system. Open system means, as you seen the word open means there is some open nature, I think. Okay, so that is the first idea after seeing this word. So you have to crack the word first, so you can get a brief and the crisp idea. Okay, in an open system there is a exchange of energy and the matter between the system and surrounding. Okay, so open means it can be it can be uh, it can be it can be provided, means it can exchange the energy as well, the energy and the matter as well. Okay, because that is a open system. That is given in the figure 5.2. This 5.2, the A system, that is the open system. So as we study, that is a system, a beaker, and there is a NaOH and water solution that present in system. Okay, so when we add the water in NaOH, it is directly start the heating, means that is a exothermic reaction. The heat has released in that process, so the heat can easily exchangeable. But the crisp concept is that the boundaries may be made up of, or it must be made up of some, that is the, we can say, the conductor medium. Okay, if there is some non-conducting boundaries there, then heat will not transfer. That we are discussing in our other isolated and closed system. Okay, so there is a crisp a twist is there. Okay, the presence of the reactant in the open beaker is an example of the open system, and the boundary is an imaginary surface enclosing the beaker and reactants. Okay, so the matter can transfer or matter can remove because that is open. The heat is also transfer because there is a conducting walls or conducting boundaries, as well as that the system is open, so heat can easily contacted with the surrounding. Okay, surrounding temperature is something else, that is a room temperature around 25 degrees Celsius, and the internal temperature of this system is around 40 degrees Celsius. So it can balanced, it wants to balanced to the room temperature. That is a tendency of the heat. Okay. The next thing is a closed system. In a closed system there is no exchange of the matter, but the energy can be exchangeable. First we have to see, we have seen, sorry, that the open system. In open system we can easily add or we can easily remove the reactant part, because that is a open. We have to control on that. But in our system, second system, closed system, that is closed, means the matter can't be exchangeable, so we cannot exchange or we cannot add or remove the reactant part in that. But the boundaries are again conducting, so it can be exchangeable of the heat or energy, we directly say. So I have to say you that the term heat I am using as an energy, because it is a form of the energy. The work is also the form of the energy. So if I use the energy word for heat and work, so don't be confused. I am saying about the these terms. Okay, heat and work. Okay, so the exchange of the energy is possible between the system and surrounding. The figure 5.2b is represent this closed system. This figure 5.2 is the b part. Okay, so it can easily understandable. Okay, the presence of the reactant in a closed vessel made the conducting material like copper, steel, for an example of the closed system, as I say you. Sorry. Then the third is the isolated system. In an isolated system, there is no exchange of the energy. As first I say in the starting, you have to crack the word that are given. Isolated means there is a no relation between the system and the surrounding. That is totally means you can say the totally different, totally differ from other. Both are separable. Okay, so isolated means there is a no relation between the system and surrounding. In an isolated system, there is no exchange of the energy or the matter between the system and surrounding. The presence of the reactants in a thermoflask or any other closed insulated vessel is an example of the isolated system. As I say to you in the first example, if the wall is conducting, then the heat can be exchangeable, or we say the energy can be exchangeable. But if the wall is not conducting, the wall is not made up by the conducting material like copper, steel, or any other metal, we can say, then, or some glass is also sometimes the exchangeable of the heat. Okay, that is the conducting part, means only say the semiconductor. Okay, but there is some conducting, the heat can be exchangeable. But I said that, but there is some crisp twist is there. If the boundary is made up of some foam, or some you can say some there is two boundaries, for example this and this, both are made up of both in between there is no air, means there is no particle to provide the medium of exchange of the energy, means there is a insulator, a vacuum is there, we can say that directly. So the heat can't be exchanged. You can say that all of us are using the Milton bottles and some other branded bottles for the make the water for 24 and more than that, the hot as well as cold. So the companies are claim that the water can be make as it is. At the starting you have to that you have fill. Okay, then what is the reason behind they have claimed? The reason is that there are two walls. First wall that is made up of metal, and the second wall is also made up of metal. But there are some different metals that they are used. First one, for example, there is a copper wall, and second one there is a some stainless steel wall. So the metal play a very important role in that. But the twist is not in the metal. The twist is that there is no medium. There is a means what is the medium of transfer of the heat between the system and surrounding? There is some particles. There is some particle of anything, air and some surrounding. For example, there is some moisture particle. Okay, there is some gas particle. Okay, so that particle took the energy from the system and provide to the surrounding. So that particle is not there, there is no medium, there is total vacuum. So vacuum means no particle, no medium is there, so heat can't be transferable. That is a twist in bottle. Okay, now I think you have clear that why the water is that we have filled is the water is remaining as it is, that we have filled in the starting. Okay, same thing, the isolated system, there is a beaker, the same, there is a NaOH and H2O solution, the heat is there, but the boundaries are made up of insulator, so heat can't be exchanged, the beaker is closed, so matter can't be exchanged. So that is an isolated system. Now I think you have clear the state of the system. Next topic. The system must be described in the order to make any useful calculation by specifying quantitatively each parameter such as the pressure, volume and temperature. So the thermodynamics is totally moves around the three, basically mainly three terms: pressure, volume and temperature. Okay, and these terms that we are use in our thermodynamics, it may be pressure, volume, temperature, gives free energy, enthalpy, internal energy, and many more. Okay, these all are the terms that we are going to use in thermodynamics. But we have to get some idea that these are called the functions that we have discussed in mathematics in our 11th class. Okay, these are the functions. Function means, that is a new word I think for you as a 11th standard student. So function means we have to apply these terms on some other or the same tools. Okay, so that are the functions. Okay, but we did not have an idea that the function is state function or a path function. Means that are depend on the path that we are using to go through from A to B, or that is a state function. Means the state is involvement, the involvement of the these states. Okay, for example, it may solid, it may gas, because states are three basically. Okay, generally the state has five: the solid state gas, gas, solid, liquid and gas, then the Bose and Einstein condensate and the plasma. But basically we are using the three state. Okay, solid, gas and liquid. So the state may affect, that is the case of a state function, and the state is not involved in that, so it may a path dependent function. Means the path we are choosing to go through from A to B, that may affect. So that we are discussing. So we specify the state of the system by state function or state variables. The state of the thermodynamic system is described by its measurable or macroscopic properties. Okay, so that is very important line. You have to underline that the state of the thermodynamic system is described by its measurable or macroscopic bulk properties. So that is a measurable, you can measure. Okay, because it is a macroscopic means, macroscope means bulk. Okay, these are two terms: microscopic, that we are discussing later classes in your colleges, and the macroscopic that we are go through, because it can be measurable, you can see, you can feel, it can be measurable. We can describe the state of a gas by quoting its pressure, volume and temperature and amount, okay, that are represented from the N. Okay, variable like PVT are called state variables, the state function, because their value depend on the state of the system, not on how it reached. Okay, that I have discussed here. The pressure, volume and temperature, that are depend on the system, state. Okay, because their value depend on the state of the system. So what is the state? That is, state is liquid, state may a gas, state may a solid. In order to completely define the state of the system, it is not necessary to define all the properties of the system. Okay, the state of the surrounding can never be completely specified. Fortunately, it is not necessary to do so. So basically you have to have an idea. First of all, you have an idea that what is the state function. State function means there is no involvement of the path that we have to choose to reach from our desirable in the starting point. Okay, That is only depend on the state. Then the next topic is that the internal energy is a state function. Okay, so when we are talking about our chemical reaction that we are using in our laboratory, and there is some losing or gaining in the energy. For example, that we have discussed that when we add the NaOH, when we add the water in our NaOH pellets, that the heat is starting to generate. Okay, so that is a gaining of the energy or losing of the energy. You can say to me in comment box. Okay, so that is a losing of the energy, because when we add the water, it is the process is spontaneous process. So the heat is generating instantly when we add the water in that. So that heat is released from the solution. Okay, so that is the exothermic process, that the heat is losing. Okay, we need to introduce a quantity which represents the total energy of the system. At that time we have to explain in our mathematical terms how much amount of the heat are losing and how much of the heat can gain. Okay, so we can't express in our theoretical, so that we have to use some mathematical tools, that we have used some terms to represent the total energy of the system. It may be a chemical, electrical, mechanical, or any other type of the energy. So chemical reaction I have already explained to you. Electrical means there is some in our 11th and 12th class you have studied about the electric cell. There we discuss the thermodynamic aspect. Mechanical, you are all of us you are all of the student are know that when we are using some, for example, uh, the cycle, all of us are using the cycle in our childhood. Okay, though, so when we using the pedal to move the wheel, okay, then you can feel after some long time when we are using when you touch the pedal area, the gear type area, so you can feel that there is some heat is there. So where the heat, how the heat can generate. Okay, so that is we are discussing. So the mechanical, we can generate the heat also. So or any other type of the energy you may think, the sum of all these energy of the system. In thermodynamics we call it the internal energy. That is the internal energy. Internal energy, there is some factors behind the internal energy, that the particles is there, the collision of the particle is there, head to head collision is there, then the generation of the product is there. Okay, for example, there is some NaOH particle in our system, there is water molecules. So the NaOH molecule and the water molecule, when they are collide to each other, because particles, NaOH is a ionic system, you all of us know that. Na plus OH, when we did not add the water, that is present in a solid form. Okay, but sorry, when we add the water in that, it is convertible into ionic form. Now Na plus ion is move freely and OH minus ion is move freely. These ions are moving very high speed in our solution, and these are collide with water molecules. There is a H plus and there is OH minus. So collision of the molecules, collision of the atoms in the solution is there. Okay, so that is that may the that is internal energy. Sorry, U, that is defined by the U. So whenever we use the U, that is the internal energy of the system, which may change when heat passes into or out of the system. Means internal energy means, for example, the basic example, you eat the food, it starting to digest, and you feel some energy, you feel some the stamina in your body. Okay, the same concept in our chemistry is there. So heat can passes into or out of the system, it can passes. So when we are working, then the heat can be changed in the form of work, so you feel I am tired. Okay, but when you take the food, then you feel I have some energy, I have some stamina to do the same work or the other work. So heat can passes into or out the system, work is done on by the system. Okay, so work is done or by the system. So system can do the work, or system uh, or by the system the work is possible. Means system is also the involvement of the system is there, or the system can work. The matter enters to leaves the system. Matter can enter or matter can leave the system, that we have discussed in a open and closed system. So in open system the matter can add, so or matter can remove. So if you add the NaOH pellets in more amount, that the heat will be generated more till the solution is saturated. Or when you remove the pellets from there, or you will add a little amount, the excess of the water is there but the amount of the NaOH pellet is little, then the heat is generated in the lower amount. So the collision frequency or the probability of the collision between the molecule of the NaOH and the water, or the ions of the Na plus and OH minus and H plus and OH minus respective to the NaOH and water is lesser. So the probability is lesser, means that the generation of the heat is lesser. Okay, so matter can enter or the leave the system. That may also affect the internal energy. Okay, and the second point, I think you did not understand the second part, so I can explain some other terms. There is some piston. Piston, you know, the pump of the cycle pump that we are using to fill the air in our tubes and tires of the cycle or motorcycle. Okay, so there is some piston. So the outer part, shell of the, that may be made up of metal, and that is a inner piston part that may attach with the shaft. Okay, there is some air, and there is outer area is also has some air. The pressure is 1 atm for example, and there is some other pressure, some x atm pressure. So when we push the piston towards the downward, okay, that the air is going to compress. Now the air is compressed, compression is there. Okay, so the heat can change the particle. There is some air particle that are moves very fast now. Okay, that the collision is fast, means the movement of the particle is fast. The collision is very fast. Collision is fast means the change in the energy of each particle, means the energy of the particle has changed. The energy of the particle has changed means the internal energy is also changed. So when we introduce the pressure in the piston towards downward, and the movement of the particle is fast, the particle now feels a more energy because the movement is fast. So for example, if you are running, then you feel some, you are feeling very tired, you are feeling some higher energy in your body. Okay, so the same phenomena is applied on the particle. So you feel very energetic, you feel stamina full. Okay, so the same thing is there. The particle feels, when we apply the pressure on that, the particle is start moving very fast. It feels that the more energy, and when they feel the higher in amount of the energy in that, their collide means collision of the particle is, probability of the collision is very high, the internal energy is very high. Okay, the same thing in opposed manner, that is a work done on the system. There is system, because we are specific discuss about the particle present in our piston shell. Okay, that is a system, that outer area remaining, that the remaining of the system is surrounding. Okay, that is a work done on the system. But the opposite is that when we applied the pressure towards upward. Okay, means the system, now system works. First we have seen that there is a work on the system, but now the system is working from system to surrounding. Now surrounding may affect. So when we are pushed on upward direction, then it feels again it feels very freely, so the internal energy may decrease or increase. Both possibilities are there. Okay, so that the writer is want to explain. Okay, so work is done or by the system that may affect the internal energy. Okay, I think time is over. Okay, we are discussing some next topic, other detailings, very crisp manner, another detailing phenomena. Okay, that we are discussing later. So today is enough for that. You have to think and apply it on your daily life, so you can easily explainable, or you can easily understandable the thermodynamics. Thank you.